In order to find the support reactions at a roller, rocker, and contact the beam mates at a smooth plane at A, we can start by developing our free body diagram. Now, for the free body diagram, it has all the external loads acting on it. Other than that, all our support reactions are listed. So at rocker, since we have just one support reaction acting vertically upward, that's why it is given as RC. Whereas for the roller, again, we have one support reactions as it limits the motion in the vertical direction. That's why I have a force going upward given as RB. Finally, for the smooth plane, since the plane is at an angle, our support reaction will be normal to the plane, meaning it is making a 90-degree angle with respect to the plane given here. So since we are given a right angle triangle of 3, 4, 5, similarly, our support reaction will be of the right angle triangle as well, 3, 4, 5. The only thing will be the 3 and 4 will swap its position because they are perpendicular to the plane shown. Once we have the free body diagram, we can go ahead and start applying our equilibrium equations. So to start, we can do summation of forces along the horizontal x direction equals to 0. In this case, support reaction RA has an x component that we can calculate by multiplying it with a ratio of 3 over 5. Next, I have a x component of 800 Newton force that is making an angle of 60-degree with the horizontal x-axis. So taking the cos 60 function will give us the x component. Simplifying, we get our value of Ra as 666.7 Newton. Next, we can go ahead and write our other two equilibrium equations. Now, in this case, you have to be careful which equations to pick. So if I do summation of forces along the vertical z direction, I will have two unknowns. So it's better to write our moment equation first. So for that purpose, I'm writing summation of moment at point C equals to 0. That will eliminate my unknown of RC. So writing all of our forces that is going to create the moment about point C is starting with the vertical force of RA that has a moment arm of 12. It is going to make our clockwise moment. That's why given as negative. Similarly, the support reaction RB is also making our clockwise moment, whereas the 500 Newton force acting downward is making our counterclockwise moment. That's why it is positive. Finally, I have my vertical component of 800 Newton that is calculated by taking the sine 60 function, multiplying it with a moment arm of 6. That is going to create our counterclockwise motion. Simplifying, we get our value of RB as 219.6 Newton. Finally, we can go ahead and write our summation of forces along the vertical direction equals to 0. In this case, we are going to add all the forces going in the upward direction and subtract all the forces going downward. Simplifying, we get our value of RC as 440 newtons.